So this is a really typical question. I've called it, by the way, I forgot to mention this at the start. I've called it introductory curve sketching, okay? Because I said to you before, when you know the derivative, it tells you lots of useful things about what something looks like, what a graph behaves like, okay? And so we're going to put that onto a graph. But it's introductory because there's more stuff which we're going to put onto this graph later on, which we don't quite know yet, okay? So one step at a time. So this is what a typical question will look like. It'll say part A, and it's just going to be testing your understanding of calculus, okay? And then part B, let's see if you can make a pretty drawing out of it, okay? So let's start with part A. Locate all stationary points of y equals x cubed minus x. Let's just do that bit first, okay? So stationary points, you remember, they occur when stationary points exist when, what was our condition? What was our condition? Good, so I need to find dy and dx, right? And then, once I've got it, I can solve for when it's equal to 0. Okay, so in this case, dy on dx is equal to, well, look at it, it's not that hard to work with. X cubed turns into 3x squared, and that x on the end will just turn into 1. Okay, great. So, therefore, for stationary points, I'm going to say that's equal to 0, right? 3x squared is equal to, 3x squared minus 1 is equal to 0. So let's just solve it. 3x squared equals 1. X squared equals a third. So x is plus or minus 1 over 3. So far, so good? Okay, now, it says locate all stationary points. So if we want to find where these points are, we don't just need their x coordinate, we also need their y coordinate, right? So we're going to have to take these two. This is actually two values, right? Negative and positive. Okay, and I'm going to have to bring them back into my original equation here to get their values. Okay, so let's quickly do that. Morning, grab a sheet. Okay, so we'll do the left one first, the negative one, okay? Minus 1 on root 3, that's a pretty gross number. When you cube it, what happens? When you cube it, what happens? Minus 1 cubed is also minus 1. Sorry, not the cube root, the square root of 3, you cube it. So root 3 times root 3 times root 3, I'm going to have 3 root 3, right? Okay. Now, by the way, I've sort of been a little bit messy. I mean, we could rationalize these. I could say that's negative root 3 on 3. And we could say that this would be negative root 3 on 9, right? But I'm going to let it slide. That's not really the main point here, okay? I've got some coordinates for that. That's good. That's the x cubed. And now I need the other part, the minus x, which is minus 1 over root 3. Okay, so double negative there, they're going to cancel. So I'm going to get positive 1 over root 3 minus 1 on 3 root 3. Okay, and I can bring these two together, can't I? Because this is really 3 on 3 root 3, right? So 3 minus 1, there's our value. Okay. Now, really quickly, because later on we're going to be graphing this, at this point, having worked this out, it's actually going to be useful for us to work out what is that approximately equal to, okay, like as a decimal, because I don't know what that looks like when I'm trying to picture what it is, because I don't know what this value is. So, root 3 is like 1.7 thereabouts, so 3 times 1.3 is about 5.1, so I'm guessing this is close to 0.4. Does anyone want to verify that for me? What's the actual number? Give me 2 decimal places. 0.38. 38, yeah, okay, 38. Alright, so close enough. Now I'm just going to use that for later so that my scale isn't, nuts, right? There's one of them. Now, this is one of the cool things, right? When I say I want to work out the other stationary point and its location, okay, I could go through all of this, alright? But there's a shortcut, you know, to actually work this out, right? Because earlier this year we were looking at functions with different kinds of symmetry, right? What were the two kinds? Do you remember? Odd and even. So when you look at this, okay, when you look at it, x cubed is an odd function. Sorry. X is also an odd function, okay? So therefore when you take the difference between them, you'll get another odd function. Yes? So, thank you. I can say, if I know that this is one of the roots, okay, and I've got this, sorry, not roots, stationary points. I can say the other stationary point is going to be, where are you going to be expecting? It's an odd function, right? So odd functions mean f of minus x is minus f of x, right? One side is the other side upside down, okay? So therefore, where are you expecting the other stationary point? It's going to be negative, right? One side is negative the other. So I can say straight away that this is going to be negative 2 on 3 root 3. Okay? Which is negative 0.38. Okay, good. So far what have I done? I have located all the stationary points. These are all of the different solutions. Okay? So I guess I probably should, to be neat, I should say stationary points exist at, and then I should put them in coordinate form, right? So the first one is, let's see, minus 1, bless you, on root 3, 2 on root 3, so that's one coordinate, and I've got the other one, which is the same thing, just backwards. Okay, great. Now, what's